Hello everyone. Today we are starting Unit 4. This is called Solution Chemistry. So we're going to learn all about solutions here. This will be lesson 4.1. Okay, so just a quick review here. Technically you would have seen this in grade 7 when you took ideally you would have taken the particle theory of matter. That's part of the chemistry unit in the grade 7 curriculum here. So all matter can be divided up into what's known as pure substances and mixtures. So if we look at the pure substances, that's going to include elements and compounds, molecules. Mixtures, on the other hand, are divided into two things. So we've got homogeneous mixtures and heterogeneous. So homogeneous are where they're the same throughout. And this includes solutions, okay? So we are going to be focused on solutions, and we're also going to talk a little bit about pure substances in the lesson today. Now, pure substances. So these are all examples of pure substances here. So the elements are all pure substances like gold, silver, copper, etc. We also have things with salt, so we've got our NaCl, we've got hydrogen gas, which is H2, we've got diamond made from carbon, we've got sugar, C6H12O6. These are all pure substances. Now, pure substances are made up of one component. Now, you may be confused by that because obviously NaCl, for example, is made up of sodium and chlorine, but what we mean by that is that it's all made up of the same compound. So it's sodium and chlorine bonded together. So pure substances are going to include molecules, atoms, and compounds, and they are characterized by definite properties. So they've got a defined melting point, boiling point, density, vapor pressure, etc. All those things would be defined for them. Now, solutions, on the other hand, we've got 6 separate properties for these. They're made up of more than one substance. So we've got the solute and the solvent. So these terms should be, hopefully, well, maybe not. From grade 10, they should have been familiar to you. So which one is which? So salt and water. So if you put salt into water, you are going to end up with salt water, right? The salt will dissolve. But in this case, which one is the solute and which one is the solvent? Now, hopefully you knew that the salt is the solute, the water would be the solvent, and they combine then to make what's known as a solution. Now, you can write these definitions down here. So the solute can be defined as the substance that is dissolved, and the solvent does the dissolving, and it is present in greater amounts. So basically, whatever you have, the thing that you have more of is by definition the solvent. The thing that you have less of is going to be the solute. Now, a second property of a true solution here, solutions are what's known as homogeneous mixtures. This means they're the same throughout, so you can't see any of the different parts. So if you have like a glass of Kool-Aid sitting there, you can't see any crystals there. It's all dissolved. That would be a solution, right? You can't separate them into their different parts here. So a heterogeneous mixture, this would just be the opposite here, where you can see be able to see that, whereas a homogeneous mixture, they're all mixed in evenly, so you cannot see their separate parts. Third property, they are clear or translucent or transparent. They are not opaque. So transparent, you can completely see through it. Translucent means light can get through. Opaque, light cannot get through. Okay, so by definition, solutions have to be either transparent or translucent. Number 4, they will not settle out. So this is a example of like muddy river water. If you go scoop out of the sunborn, well, hopefully it's not this dirty, but if you were to scoop some river water, you wouldn't get it fully clear, right? But eventually a lot of the particulate would settle out, so you'd collect it on the bottom here. So when that happens, that is not a solution, okay? So this is not a solution here. A solution will stay what's known as staying in solution, so it won't precipitate out. Next, number 5, it can be separated into its components by distillation, not filtration. So the image on the left there is distillation. So if we look here, we've got water. This would be our water in here. Now, as we heat it, this is seawater, so this would be salt water. Okay, so salt water. As we heat it, the water is going to, I should switch to blue here. As we heat it, the water droplets are going to evaporate, and then they're going to come out here, and they're going to cool as they go through this tube here. This would be the distillation column, and then what happens is it would end up collecting over here, and that would be your pure water. Now, what would be left over here then? Yeah, so that would be where your salt would collect there. So you can separate a solution through distillation. You cannot separate through filtration. Now, if you looked at where's that, this river, you could use filtration for this, right? If you poured this through filter paper, this would be filter paper in here, it would collect all the larger particles there, all the larger solid particles, and then you'd collect the water in the bottom. So filtration, again, not for a solution, only distillation is going to work. For the next one, number 6, properties vary depending on the amount of pure substances present. So this is potassium permanganate, I believe. So two solutions, it's the same chemical, but we've got different concentrations, and we can see that by the different colors, right? We know that this has got a higher concentration. X has a bigger concentration than Y here, and we know that because of the vibrancy of the color. So looking at this, these would have different properties because they've both got different amounts of water and the chemical. And so because it's got different amounts, the properties will vary depending on how much stuff is in there. Okay, now there are 9 types of solutions. So we went through the 6 properties, and now we're going to have 9 types of solutions. Not lots of numbers today. So the first type of solution we have is a solid dissolved in a solid. Now this feels very counterintuitive. How can that happen? That's not a thing, right? But it is a thing. So you can have a solid dissolved in a solid. Often you need another medium in order for it to happen, but it does work. So this here is our sterling silver. So sterling silver is, hold on here, oh boy. All right, so this is copper in silver. So that would be copper in Ag, and that's what sterling silver is. Over here, you might have some of this in your home, is brass, and brass is actually zinc in copper. So zinc in copper. So both sterling silver and brass are examples of a solid being dissolved in a solid. Solid in a liquid, we've got our sugar and water, so that one's pretty basic, right? We take our solid sugar and we dissolve it in our water. Next one, we have solid in a gas. So again, this one feels a bit weird too, right? This could be microscopic particles in the air. So this is our coronavirus here. So if we have these little particles in the air, this would be considered a solution. We can't see them. They're there. Now, number 4, liquid. You know, this one wouldn't, now I'm thinking about it, I don't think that'll actually work for the coronavirus because technically you could filter that out. So maybe we won't use that as an example, but other microscopic particles, think of that in the air. Number 4, now we're going to move to the liquid. So when we have a liquid dissolved in a solid, so some of you probably have tooth fillings that look like this still. They don't always do them. Now they use a different method, but mercury and silver amalgams, so that would be mercury is liquid, and you would dissolve it in silver to make these. Liquid in a liquid, if we have, my kids like to do this, they like taking 7-Up and putting it in orange juice. When we've got those 2 liquids together, they dissolve in each other, right? And so we've got a solution, our final solution here. Number 6, liquids in a gas. So this, as an example, we could just think about water vapor being dissolved in the air. So when we have this evaporation here, that's water vapor that is collecting in the air. So that's our liquid that's dissolving in our gas. So that would be humidity, right? So when we talk about a humidex or humidity level, that's what we mean by that. Gas in a solid, so this would be gases in a charcoal filter. this would be our activated charcoal here, and that just shows how gases enter in and they get dissolved in the carbon filter here. Number 8, gas in a liquid. Most common one that most of us have experience with would be carbon dioxide in a soft drink. So anytime you have a carbonated beverage, that's a gas being dissolved in a liquid. We could talk about dissolved oxygen in water, anything like that. And number 9, lastly, a gas in a gas. So an example of this is simply our atmosphere. We know that nitrogen makes up the vast majority of our air that we breathe, of our atmosphere. So oxygen is 21%. So oxygen gas technically would be dissolved in the nitrogen gas. So this would be a solution together, but the one that is the biggest will be the solvent. So nitrogen then is going to be our solvent here, and then the oxygen and the other gases would be our solutes. Okay, so that's it for that, and we'll get going on our next lesson a little later. Thanks, everyone.